kid. I'm going to do a recording on exponential equations. Exponential equations. You just write down the title here, so that you can actually get some sense of what it is. Just want to make sure my spelling is correct. Exponential equations. Yeah, there you go. Okay, exponential equations is actually a topic that's actually linked to the topic of indices, the topic of surds, and even logarithms even. So you have to be actually well versed in exponential equations even before moving on to logarithms. So what's an exponential equation? An equation that contains a variable and an index is called an indicial or exponential equation. Now the simplest form is in this form: a to the power of x equals to b. Now if b can be expressed as if b can be expressed as a to the power of n, then we know that a to the power of x equals a to the power of n, and therefore x equals to n by comparison. Okay, so this is what is known as an exponential equation. Now, of course, in this case, a is not equal to -1, 0, or 1. Alright, so let me give you an example. Okay, 4 to the power of x equals to 1 over 16. Okay, 4 to the power of x by the law of indices is equals to 1 over 4 squared. 4 to the power of x equals to 4 to the power of -2. Therefore, by comparison, x equals to -2. Alright, so this is an example of an exponential equation. Let me give you another example. 5 to the power of x squared minus 1 equals to 1. 5 to the power of x squared minus 1 equals to 5 to the power of 0. Now remember, a to the power of 0 equals to 1. Okay, anything to the power of 0, in fact, is actually equals to 1. So from here we can see that by comparison, x squared minus 1 equals to 0. Now, how do we factorize this? Can you remember this formula? A squared minus b squared equals to a plus b bracket a minus b. Okay, a plus b multiplied by a minus b. So this x squared minus 1 can be factorized as x plus 1, x minus 1 equals to 0. Now let x plus 1 be equals to 0. You get x equals to -1. So I just let this equals to 0. Okay, and let x minus 1 equals 0. X minus 1 equals to 0. I get x equals to 1. Therefore, x equals to -1 or 1. That's your answer. Alright, yet another example. I hope I'm not going too fast here. Let me just shift down the page here. Okay, if I have 9 to the power of 2x plus 1 minus 27 to the power of x equals to 0, 9 to the power of 2x plus 1 equals, let me just shift 27 to the power of x here, minus negative, I shift to the right hand side, it becomes positive. Now the problem is that these two bases are unequal. Alright, these two bases here are unequal. So let me make it of the same base. What do? 9 can be expressed as 3 squared power of 2x plus 1, and 27 is 3 cubed to the power of x. So if that's the case, according to the law of indices, what I have here on the left hand side of the equation is 3 to the power of 4x plus 2 equals to 3 to the power of 3x. Now, you can remember that 3 to the power 1 equals to 3, 3 to the power of 2 equals to 9, 3 to the power of 3 equals to 27. You know, remember this few, it actually help you in exponential equations. 2 to the power of 1 equals to 2, 2 to the power of 2 equals to 4, to the power of 3 equals to 8, 2 to the power of 4 equals to 16. Okay, these will actually help you to solve your exponential equation, so be well versed in this. So looking at the exponential equation here, we know that by comparison 4x plus 2 equals to 3x, okay, sorry, 4x minus 3x equals to minus 2. What I did was just shifted positive 3x to the left hand side of the equation, therefore I get minus or negative 3x. I shifted positive 2 to the right hand side of the equation, okay, to the right hand side of the equation, okay, and 3x to the left hand side of the equation, okay, and since I've just shifted positive 2 to the right hand side of the equation, I get a negative 2. So 4x minus 3x equals to x equals to negative 2. There you go. So these are just some of the basics of exponential equations. Of course, there are a lot more complicated situations. Let me just give you another example, okay, to sort of sum it all up, okay, give you some sense of the kind of questions that that might come out during your exam. Yet another equation would, yeah, okay, they might give you a question in this format: solve the following simultaneous equations, EQNs, alright? Sure. Okay. They will disguise the simultaneous equations in the form of exponential equations. Alright, equals to 16, and then 3 to the power y over 27 to the power x equals to 1 over 3. Okay, let's do this here. Now, 4 is also 2 to the power of 2, okay, x times 2 to the power of y. 16 is actually 2 to the power of 4. 2 times 2 times 2 times 2, that's 16. So what we get here is 2 to the power of 2x times 2 to the power of y. Okay, this dot here actually signifies multiplication. Okay, and according to law of indices, you can add 2x plus y equals to the power of 4. Now 2 to the power of x plus y equals to 4. Let's call that equation 1. Alright, let's do this here. Okay, we get 3 to the power of y. Now 27 is actually 3 to the power of 3 bracket x equals to 1/3 is actually 3 to the power of minus 1 according to the law of indices. Okay, so next step, 3 to the power of y equals to 3 to the power of 3x equals to minus 1, and according to the law of indices we can, oops, I've just made a mistake, let me just erase this. It's actually 3 to the power of minus 1. So 3 to the power of y minus 3x equals to 3 to the power of minus 1. Okay, therefore y minus 3x equals to minus 1. Let's call this equation 2. Okay, from equation 2, let us derive 2 prime. Alright, we know that if we shift negative 3x to the right hand side of the equation, negative 3x will become positive 3x minus 1, okay, and let's call this 2 prime. So we've got 2 equations to contend with right now, from which you can solve the whole question. Let us move on to the next page. So 2x plus y equals to 4, right? That's equation 1. And the second equation is y minus 3x equals to minus 1. If you remembered, I manipulated it and I got y equals to 3x minus 1. This is 2 prime. Okay, let's substitute 2 prime into equation 1. So 2x plus y, you know y, there you go, 2x plus y equals to 4. Since we know y is equivalent to 3x minus 1, so we just do some substitution. Alright, okay, equals to 4. 2x plus 3x equals to 5x minus 1 equals to 4. Okay, I shall shift negative 1 over to the right hand side of the equation. I get 4 plus 1. 5x equals to 5. X equals to 5 divided by 5. X equals to 1. Alright, now when x equals to 1, we just solve for x. When x is to 1, let's solve for y now. Y equals to 3 times 1 minus 1. Y equals to 3 minus 1. Y equals to 2. Alright, so we've just solved simultaneous equations embedded within exponential equations.